Hello, Trig. So today we're looking at the power rule, which is one of those shortcuts I mentioned that we're getting to in order to find some derivatives so that we don't have to go through and do the whole thing the long way every single time we want to find the derivative of something. But we're going to start off with one of those the way we were doing it last time. So let's say I've got x squared and I want to find the derivative. Now the way we were doing this in the last section is we can take x minus h, plus h squared minus x squared. So we got f of x plus h and then f of x over h, because remember we're using that to find our slope, because we got y2 minus y1 over x2 minus x1 just turns out to be h because we were calling that difference h. Okay, and then we're squaring that, so again x plus h times an x plus h, which is really an x squared plus an hx plus another hx, so plus a 2hx plus an h squared minus that x squared there over that h. And then we're just making that look simpler. So I've got an x squared and a minus x squared here that are going to cancel, and we can factor an h out of both of these on top. And then our h's are going to cancel. And we said we wanted the limit as h is getting closer and closer to 0. So as we're making that difference between our 2 points smaller and smaller and smaller and smaller and smaller as it's approaching 0, this is really just going to be 2x. So there's our derivative the long way. Now, the power rule and what we're about to do with these is that we can take this number that's up here and it can jump out here, and then this exponent gets bumped down by 1. So we usually don't write that 1 in there, but I'm going to write it in there just so we can see that the exponent isn't just disappearing, it's getting bumped down by 1, which is the power rule, which is the first thing you're probably going to want to jot down. So that first bit there is just saying what we just said. So this is another way of writing the derivative. So the derivative of anything to the power, so if I have x to the any power, I can take that power and it's going to hop out here and then subtract 1 from my exponent. So anything where we just have x to an exponent, we can do that. Also, if we're adding things that look like that, we can just find these separate derivatives and add them. And if we're subtracting anything that looks like that, we can find the derivatives and subtract them. And if there's a number outside, it just stays outside. So these last three are kind of, more common sense, but there are different things that we can do with derivatives. So if we can find the derivative of this part and the derivative of that part, we can just add them together and we get our derivative. Same thing with subtracting, but not importantly, multiplying or dividing, which we're going to get into in the next section. All right. So if we've got something like this, rather than going through and finding the derivative the long way, I can say I'm going to take that 7, and it's going to hop outside of my x to the 7th. So now I've still got this 5 here, and I've got this 7, and we've got x to the, this gets knocked down 1 power to an x to the 6th. This minus stays minus. We've still got that 3, and that 4 is hopping out here. And technically that 4 could either hop out here or hop out here, because it doesn't matter if I'm taking 3 times 4 or 4 times 3. And then I'm taking x to the, this gets knocked down 1, so the 3rd power. And then we're just making that look nice. So 5 times 7 is 35. Minus 3 times 4 is 12. So there's our derivative of x. Yay. So much faster. And we can also use this for things that don't immediately look like that. For example, if I've got something like this, if you think back when we were talking about square roots are just another way of writing fraction exponents. So the square root of x is really x to the 1/2. And if I have an x on the bottom of my fraction like that, that's really an x to the negative 1st power. And we still got that 4 up there. So that's just another way of writing this. So we can still do the same thing. So if I want to find f prime of x, which is just another way of saying the derivative of x, so little apostrophe there, you can just say prime. So that 1/2 is hopping out here. So we got a 1/2 Now, what happens if I take a 1/2 and I subtract a 1? Ooh, I get a negative 1/2. I'm going to assume that's what you said. And then we're taking that negative 1, that's hopping out here, getting multiplied by this 4, so this is a negative 4 now. If you want to change that into a minus 4 instead of plus a negative, that's fine. And then that x to the negative first, negative 1 minus another 1 gives us a negative 2. And there's our derivative. Yay. So much faster. Much faster than the other way we were doing these. Alright. Let's do one more. So let's say we want to use this one to find f a double prime of x. And all that means is we're going to do it twice. So instead of finding the first derivative, we're finding the second derivative. So we're finding the derivative, and then we're finding the derivative again. And you can do that as many times as you want. You can find a third derivative, a fourth derivative, and you can just keep on doing this. We're just finding the second one. No. Okay. And just a heads up that sometimes you'll see it written like this. Sometimes you'll see that written like this. Just like sometimes you'll see your first derivative written like this, and sometimes you'll see it written like this. So this means we want the derivative of the function f with respect to x. This means the same thing, but with the second derivative. So if you see this, it really means the same thing as this. In the book, I'll use these two pretty interchangeably. So this means the same thing as that. Alright, let me write that. A little bit more room here so I don't have to go off the whiteboard. Alright, so now this one, before we can do that, we're going to have to deal with the fact that we got a 2x on the bottom here. So I'm going to split this fraction up and call this a 2x to the 5th over a 2x minus a 5x squared over a 2x plus that 3 over a 2x, which makes it a little bit nicer. If we want to make it even nicer, we can take these 2's and cancel them out. X to the 5th over an x is just an x to the 4th. And then minus 5 over 2 is just 2.5. X squared over x is x. And then we got a 1.5, and instead of an x on the bottom, I'm going to call this an x to the negative first. Now, we haven't done anything with that, so that's not our derivative yet. That's just the original function. So this is still f of x. Now we're going to find our derivative. So f prime of x, that 4 is hopping out here, so you got a 4, and then that exponent gets knocked down 1. There's not a number there, and when there's not a number there, that's really a 1. So that 1 is hopping out here, that's really not going to do anything to that 2.5. But when that gets turned into an x to the 0, anything to the 0 power is just 1, so that's gone. And then we've got a negative 1 there, so that's going to be a minus 1.5, and this is now an x to the negative 2, because we subtracted 1 from that exponent. So that's our first derivative. Now we're going to do it again, because we wanted f double prime of x. So we're going to do it again. So we're going to take that 3 there. That hops out front. 4 times 3 is 12. X to the 3rd gets knocked down to an x squared. This is gone. Because technically we've got an x to the 0 there, but when that 0 hops out there, it doesn't matter what else is there. This is just gone. And then we've got, but don't lose this negative, because we've got this negative 2 times this negative 1.5, which gives you a plus that 3. And now that's an x to the negative 2 minus 1 is a negative 3rd. So there's our second derivative. And really the big thing to watch out for there is watch out, don't lose that negative, just because this is going away. So that negative goes with this, not this. So watch out for disappearing negatives. Alright, and that is pretty much that. So much faster than the long way of doing this. In the next section, we'll get into, well, what if we're multiplying those? What if we're dividing those and it doesn't divide out nicely like that one did? That's in the next section, but for now, go ahead and check out the homework in the description, and I'll see you in the next video.